So we just saw a quick demonstration of the Phi-3 shield with an alarm clock program. It's still running, and we're interested in taking a look at what Phi-3 shield actually has. So let's take it apart. The display is already unscrewed, so as you can see, it's not exactly tight. So I took the bolts off. So let's unplug it and just remove the display. The display is actually connected to the main shield board with the 4 wires, because the display itself has a backpack. This is a pretty typical I2C display with a backpack. You can buy it at a lot of different places, but you need to make sure the wiring is correct. So that's a display there. Let's put it outside. So with the display removed, you can see all these connections. These are the Arduino stacking headers. Even with the display on top, you can still connect to them. You just have to use these flat jumper wires to connect to these places. So there's no issue connecting to them at all. And this is a micro SD card breakout board. You can remove it if you want. You don't really have to have one to run the alarm clock code, but it'd be really nice to have this for your data logger project. So integrated onto the board, you can see there are buttons, 4 button direction buttons, and 2 buttons here, confirm and escape. And that is a reset button for Arduino. There's also 2 LEDs here and here that you can use to use as indicators, and you're free to choose what pins to drive the LEDs with. So what I did here was I had jumper wires here that are connecting the LEDs to these analog pins that I can use as digital pins. One of the jumper wires is connected to the speaker, so I can use the speaker with one of these pins, and the other 2 are the LEDs. And the indications are actually printed on the board, so you would be able to see it if I zoomed in. But let's just do the overview while we can zoom in later. And over here, there's this area that you can put an Adafruit Ultimate GPS module. All the pins are broken out here except for the 3.3 volt pin that is not useful. So you can just pop that one in and solder on the back side. And these 2 jumper wires are connecting the GPS module to one of the Arduino Mega's serial ports, hardware serial port. And here's another feature. Since Arduino Mega has so many pins, these pins that are not used are basically not blocked. I cut a slot around these pins, so you can still drop your jumper wires here, make any connection that you want. And there's also these mounting holes. These are standard Arduino Mega mounting holes. So 2 on the right side, 2 on the left side, to ensure that if you want to mount securely, you can do that. These are all lined up with the Arduino Mega's mounting holes. And here's just one mounting hole for the GPS module, in case you need it. Let's flip it to the back side. So on the back side, you can see this is the real-time clock module, the DS3231, with 32 kilobytes of EEPROM. So there are two modules on this breakout board. You can remove it if you want. So as you can see, there are 2 ICs. The bigger one is the real-time clock. The smaller one is the EEPROM. So this is also pretty popular on lots of websites such as eBay. But do test their qualities before you commit it to a project. That's why I have these connectors, these headers, instead of having to solder them onto the board. I have these headers, so if anything were to go wrong, you can quickly replace one with another. So let's put it aside. This is the connection between the shield and the I2C LCD. So for this particular type of LCD with I2C backpack, the connection is pretty much direct. One pin from the say the top pin on the LCD will go to the top pin on this connector. You can see the color coding. The orange is top pin here. It's also the top pin on the LCD. So same pin arrangement between these 2 connections. And you can also take apart the board. just remove it from the Arduino Mega. Make sure that you do this carefully because there are so many pins that are in headers. You don't want to pull too hard to bend the pins, or you could poke yourself with those sharp pins. So just do this carefully, kind of rock it back and forth. I just want to show one feature, the in-system self-programming header that's underneath. So it's a little bit tight. I have to do it slowly, just kind of gently rock it back and forth. If you're used to Arduino Uno's shields, those shields are easier to remove because there are less pins. So with more pins, it's harder to remove. Okay, as you can see, this is the in-system self-programming header. So this connects the SD card to the Arduino Mega. And although this entire shield is designed for Arduino Mega, you can still use it on Arduino Uno. It just basically only occupies this much space. The Arduino Uno will be here. I also have 3 screws with spacers here that supports the display. So the display is actually well supported. So 3 out of 4 mounting holes. This one I don't really have it because if I had it, there would be no space to reveal the Arduino Mega's extended pin headers. So that there are these pins. Well, overall, this shield is an upgrade from the Phi-2 shield, which was an upgrade from the Phi-1 shield that I started quite some time ago. So, thanks for watching.